Hello YouTube. As you all know, internet is a magnificent technology and to understand how it works takes a lot of pain and effort. I thought I can just make a video and try going through how the internet works, how these IP addresses work and all of that. So for this video, I'm going to take a simple example of just a normal web developer who has built his or her own website, and we are going to make sure people across the world can access their website. Okay, so let us quickly jump in. I've made a small presentation kind of thing so that we can quickly go through it and understand these concepts really well. All right, so here is the agenda for today. We're going to split this entire presentation into three parts. The first part is we are going to look at how to get an IP address or how to procure an IP address. The second part is something called as BGP registration, which we will look at in the future. And the third part is the life of a packet. That is how the packet will flow from a client who wants to access your website till it reaches the server where the IP is binded. Okay, and one more thing I wanted to tell you here is that I'm going to put the link of the slides of the presentation in the description below. So I would highly recommend you to open the presentation as well because it contains a lot of links which you can navigate to. Okay, so the first part, how do you procure an IP? Okay, how about 127.0.0.1? It's obviously local host, so you do not have to procure that. How about 192.168.1.2? This is a private IP address, so it is not necessary to procure it. It is more like you can use it for your personal use. Okay, the other people in the world cannot really look at the IP address or look at this private address, so they cannot reach it. So this is of no interest to us. Uh, Obviously, if you do not understand the difference between private and public IP, you can go check out a lot of other videos which are there on YouTube. We are not going to talk about that right now. So for this video, we are interested in knowing what a public IP address is and how do we procure it. That is what is important. Okay, and the good thing about public IP address is that it is accessible throughout the world. So anyone who knows your public IP address can reach it. Okay, so there are a few important concepts or concepts or terminologies that you need to understand before you dive into buying an IP address. Okay, so first thing is IANA. What is this? So IANA stands for Internet Assigned Numbers Authority. Okay, and this is mainly responsible for coordinating between your DNS root servers. It helps in allocating and deallocating IP addresses to organizations and various other internet protocol resources. And there is also something called as ASNs, which we will come to in the later part of this video. The next thing is something called as regional internet registries. So if you look at this, right, IANA is a big organization, but it is impossible for one organization to uh, assign IP addresses to everyone else in the world, right? So it kind of delegates its responsibilities to something called as regional internet registries. Okay, these are like sub companies, you can tell, of IANA, which are spread across the globe, which handle their own region. Okay, this is something very similar to the DNS hierarchy that we have seen in our previous video. So basically there are 5 regional internet registries in the world, and they are for different regions, obviously. So we have one for Africa, one for America, one for Asia Pacific, one for Latin America, and one for European regions. Okay, and these are the short forms that are used for each of these registries. Okay. I think we will come across these in the later parts of the presentation as well. So I think you should just have a look at this. Okay, so the next thing we are interested in is what is an ASN. So ASN stands for Autonomous System Number. Uh, okay, is that all we want to know about? Absolutely not. We are not here just to understand what it stands for. So let us dig a little more deeper. Okay, so ASN is a number which is used for exchanging routing information between other autonomous systems. Okay, and to understand this, you obviously need to know what an autonomous system is. So, an autonomous system or an AS is a group of IP networks which are operated by one or more network operators that has a single and a clearly defined external routing policy. Confused? Yes, even I was. So basically, in simple terms, what this means is once you procure an IP or a range of IP addresses, you try to associate that with a autonomous system. So basically, an autonomous system is just a bunch of IP addresses, and they have routes. Okay, so that other neighboring autonomous systems know that this IP address belongs to you. It's as simple as that. Okay, so any client or any person who wants to access your server can travel along other autonomous systems to reach your autonomous system. I hope this is clear. If you want to know more about what autonomous system numbers are, I would highly recommend you to check out this FAQ. This is by APNIC. I hope you recollect that we had seen this in the previous. Okay, so they've got a quite number of interesting questions here and a good number of answers to them as well. This is quite interesting. You might want to check that out. Okay, so now we have kind of covered the concepts that are important to us to buy or procure an IP address. So let us quickly move on. The first requirement is to get an autonomous system number from your regional internet registry, right? So you contact your regional internet registry based on the location that you want to place your server in or place the IP address in. Let's say it is in India, then you would go contact APNIC. Okay. Similarly for other regions. Now, this is not a mandatory step because you can actually borrow ASN numbers from different providers and have your IP transited along with them. So you can basically allow them to use your IP addresses and you have your servers behind those ASNs. Or you can have your own ASN and you can have your set of IPs behind your ASN. Okay. So basically, what it takes to have your own ASN is to just have your unique routing policies. You need to have a BGP router, and you have to basically fill out a couple of forms and agreements and all of that. And for that, Aaron has already made a video for that, and you can go watch this out if you want to get your own ASN. Okay, so now let us consider that we have actually gone and requested for an ASN and we have got a number, the autonomous system number for ourselves. Okay, so the next step would be to go request for an IP space. Okay, and ARIN again has a video tutorial for this as well, so I'm not going to cover that. It's just again filling out a couple of forms and basically you need to give your organization ID and give the point of contact's email ID and all of that. Okay, it's quite simple. You can just watch this video to get more info about how to fill out the forms. Uh, Now, what might interest us to know how much the IP address might actually cost us, right? And here is the list. So basically, /24 here means that you're going to get approximately 254 IP addresses, okay, and it is going to cost you approximately $250. So this basically means that you're approximately spending around $1 for each IP address that you procure. Okay, and the list goes on. If you want a lot more number of IPs, you will go for bigger plans here. Okay, this is how much it would cost for you to procure an IP address from the regional internet registry. Yeah, now we finally have an IP address. So one more important thing which I forgot to tell you is that a lot of people keep putting this on the internet that IPv4 is exhausted. You cannot really use IPv4 anymore. You do not get IPv4 addresses anymore and all of that. So I have a quick link here which has the waiting list for IPv4. So we can go have a look at that. And this is specific to ARIN registry. It's not like by IANA. Okay, so if you notice, there are people who are waiting in the queue from the 2nd of May. Okay, and they have requested for like /20 to subnet, and we all the way go down and we see requests till the 13th of December, which is like 2 days ago. Okay, so basically the wait time is approximately 6 to 7 months as of now, and it might keep increasing in the future. So basically, you have to wait for approximately 6 to 7 months just to get an IP address, right? It's not one IP address. You can only request for, I think, a /24 is the least here. So for /24, you get like 254 IP addresses allocated to you. Okay, and this is going to take approximately 6 to 7 months. So even though you have a web application developed before that, you cannot really go and publish it online and have someone else access your website till you're allocated these IP addresses. So let us move on. So now that we have our IP address and our ASN, we should go ahead and start talking about something called as BGP peering, advertisements, and all of that. So first thing is you have a autonomous system number, okay, and you're going to start talking to other autonomous systems or your neighboring autonomous systems, and this process is known as BGP peering. All right, so you basically set up routes and cables between different autonomous systems. Let's say my autonomous system name is Aditya, and I have my friend Noel who is in the next autonomous system. So basically, I have to have physical connection or a physical wire present between my autonomous system and his autonomous system, and this can just be between two IP addresses. Noel can have like 50 IP addresses, I can have like 200 IP addresses. All we need is one connection between one IP of mine and one IP of his. Okay, so basically these are done by BGP routers, and this physical connection needs to be established first, and then you can do something called as BGP peering, which we will look in the later slides. Okay, and the reason we do BGP peering is for other or the neighboring autonomous systems to know that these are the IPs that we are using or we have on our autonomous systems, so that any traffic that comes to their autonomous systems which is for our IPs, they can forward it to us. Okay, so that is how the internet works. It is just forwarding it. Basically, each autonomous system checks if the IP belongs to them. If not, they just forward it to where they think it might be. Okay, and all of these is controlled via routing tables. Okay, so let us have a quick example here of how BGP peers look like. Let me change this to India. Oh, okay, this is Tata Communications, and if I click on this, okay, before clicking, let me show you that uh, this is one autonomous system which Tata Communication owns, and the autonomous system number is 4755. And as you can see, they have peered along with like say hundreds of other autonomous systems, right? So if you notice, the lines that join the other autonomous systems are peered by Tata Communication. Okay, so if we just click on this guy, we can see a lot of details here, like the POC contact, email ID, and all of that. So you can mail them if you feel something is wrong. The other thing that we are interested in here is known as peers. Okay, we were talking about BGP peering, right? So when Tata was established, Tata Communications was established, they started peering along with the other autonomous systems which were present. Okay, and we see two sections here. One is upstream and one is downstream. The upstream basically means that Tata Communication is paying these companies or these autonomous systems to spread or to basically propagate their routing tables to other autonomous systems. Okay, so basically, if any of these two upstreams get a packet or get traffic for Tata Communications, they basically forward it, and that is what they charge for. Okay, and Tata Communications have a lot of downstreams as well. So basically, these are the autonomous systems that pay Tata Communications for Tata Communication AS to forward packets to these guys. Okay, so there are a lot more downstreams because I think Tata Communication is spread across India, so they've got a lot of places where their ASNs are present. The servers of the ASN is present, so they are able to basically provide this benefit to a lot other ASNs. Okay, so you should be able to see BSNL and all of these are also paying Tata Communications so that they route their packets to these autonomous systems. I hope this is clear. So similarly, what we need to do is we need to start peering with other people. We can either set them as downstream or upstream based on who will be forwarding the packets to whom. Once we have peered with other autonomous systems, peering basically also requires you to sign some kind of agreements and all of that with the other peers, saying that you will not basically advertise IP ranges that you do not own, right? Otherwise it wouldn't make sense if you start publishing maybe Facebook's IP address or something. All the traffic gets forwarded to your autonomous system, right, which is not legal and it is something that you shouldn't be doing as well. So since we do not own any physical IP, since we did not really go and buy an IP and all of that, I think we can safely assume that we have uh, a subnet allocated to us, which is 1.1.1.0/24, and we have 254 IPs in that subnet, which is from 1 till 254. Okay, for simplicity in this entire video, I'm going to strip off these two middle ones, and I'm just going to tell 1.1 and 1.254. Okay, and let's assume the autonomous system number that we have been allocated is 1000. So now let us also assume that we have four web applications. Okay, so we basically are going to take out four IP addresses from those 254 IP address, and we are going to basically attach them to four different servers, okay, which have our web application. So this is how it is going to look. The cloud is just a representation for us to concisely tell that this is our autonomous system. Okay, and as I said, we have the autonomous system 1000 given to us, and we have four IPs. So basically these are just networking devices for now, but they will have physical servers behind them which have the web application which will be serving traffic. Okay, so we have 1.1 and 1.4 at the edge of the cloud, which means these are BGP routers which actually accept and forward traffic. Okay, whereas 1.3 and 1.2 are inside the cloud, which means that they are not going to exactly forward externally, but they're going to help in internal routing within the cloud, within the particular autonomous system. I hope this is clear. So now that we have kind of decided our architecture for our autonomous system, it's time for us to make new friends and start peering with them. Okay, and I did find two autonomous systems next to me, and these are autonomous system 998 and 999. Do not go by the numbering because it seems closer to 1000, but that might not necessarily be the case. The numbers are here just for representation. Okay, similarly, the other autonomous systems also are denoted like a cloud, wherein each of the external gateways or the BGP routers are present on the edge, whereas the internal routers are present inside the cloud. These thunder-like lines here, which are connecting the BGP routers, are basically physical connections between these autonomous systems. Okay, and that's the first step of peering. And once you have physical connection set up, you basically start sending BGP announcements to the neighboring peers of yours. Okay, so let's say we have 1.2 and 1.3 added to our autonomous systems. So basically what we start doing is from 1.4 and 1.1, we start announcing that 1.2 and 1.3 belong to us as well. So any traffic that, let's say, 3.4 receives a packet for 1.3, it is somehow going to find a way to reach this. Okay, so since 1.4 is announcing 3.3 that 1.3 belongs to ASN 1000, we are finally going to get that packet which belongs to us. Okay, similarly the other things as well. So now let us assume that we have peered along with 998 and 999. Okay, so basically these two autonomous systems know the subnet or the entire IP range that we own. Okay? So that is what I just told. We just want to advertise our IP so that other autonomous systems know where to send the packets to. So once that is done, we should also have some kind of routing internally, all right? So for this, we can use various other protocols. BGP is one example. So there is something called as internal BGP, IBGP. So you can have various internal routing protocols which doesn't matter to the external world outside your autonomous system. So once one of these two edge routers receive traffic, they should be able to forward it internally. Okay, that is the entire motive of having internal routing. Okay, so if you notice, 1.3 is not connected to 1.4 directly. It is indirectly connected via 1.1. So any traffic 1.4 receives, it will first have to forward it to 1.1 and 1.1 will have to forward it to 1.3. Okay, that is just an example that I'm trying to show you here. Similarly for other uh, autonomous systems as well. Did I mention that BGP stands for Border Gateway Protocol? I think, yeah, I have not mentioned that. So basically, BGP stands for Border Gateway Protocol. It is just another protocol which is used for you to route packets between autonomous systems and for autonomous systems to peer with other autonomous systems and for them to advertise their IP addresses. It is basically like the backbone for your entire internet. So now that we have peered along with the other autonomous systems, we are kind of ready for anyone to actually come and access the four web applications that we have behind these four IPs. So let us look at a simple packet flow. What happens when there is a client who's sitting behind 3.3.3.1 and wants to access the application which is on 1.1.1.3. Okay, so for this example, let us assume ASN 998 is a ISP. ISP is a internet service provider. Let us assume I'm using BSNL or AT&T or some internet provider, and basically I'm present behind this 3.3.3.1, 3.1 basically. Okay, so what these ISPs do is they associate one IP address to multiple users, right? So they have some concept called NAT and all of that, which they apply on this router. So basically, any user who's trying to access the internet will have to pass through this particular router, and that will try to forward it to the destination. Okay, it's as simple as that. Let us assume our client is sitting behind this 3.1 IP and he or she wants to access what 1.3. Yes, 1.3. Okay, so if the user wants to access 1.3, let us look at the simple packet flow. The first step would obviously be from the client's home or the client's laptop to 3.1. That would obviously be the first step, and once 3.1 receives the packet, um, what happens is it tries to identify the closest route or the next hop that it has to send to so that it reaches the destination with the fastest path, right? So that again considers multiple options. For example, you have the least number of hops, which basically counts the number of devices which are in between the client and the server. The other thing it can also look at is the latency between the links. The other thing can be maybe the capacity of the links and all of these. So based on various parameters, it tries to establish a link from the source to destination, basically a routing path. Okay, and we call this a dynamic routing path between 3.1 and 1.3. So basically it identified the path and the next hop from 3.3, which is the gateway router, is to go through this peering link that we had to 1.4. Okay, and once 1.4 has the packet, if you remember 1.4 to 1.3 there was no direct connection, so it basically forwards it to 1.1 and 1.1 forwards it to 1.3. As simple as that. Now finally our client is able to send his or her packet to the web application which is sitting behind 1.3. So just for an example, we can look at some real-time autonomous system routes, and the example we are taking here is a Red Hat. Okay, so what I did was I figured out Red Hat's IP address. I did a simple whois lookup. Okay, let me just expand this so that this is much bigger. Okay, so if you notice, the original AS, which is Red Hat's AS, is sitting here. Okay, this is difficult to zoom in as well. Let me try. Okay, let's not go beyond this because it'll be difficult to look at the other autonomous systems. So basically 31976 is what belongs to Red Hat. So when I click on it, right, you can see the name here. So let me go back. Okay, so you can see that it belongs to Red Hat, and basically redhat.com has been advertised by this autonomous system. Okay, this autonomous system has been advertising for redhat.com, and anyone who wants to access it has to reach this autonomous system behind which the server is sitting. Let me zoom out a bit, uh, and we can see that there are other things that are of interest to us as well. Okay, we have these blue colors, circles or ovals, which are collector peers. So basically these help in forwarding traffic to the autonomous system that we are interested in. Then we have others, and then we have a dynamic path that is established, and we have a static path. So this basically means that whenever you have a static path, that path is always followed for you to reach a destination, and a dynamic path is basically calculated on the fly. So basically whenever you want to reach a server, a dynamic path is calculated so that you kind of meet one of those criteria that I spoke about, like latency, capacity, and the number of hops. Okay, one more thing that we can see is we can just click on the play here, and we can see a lot of dynamic routes and static paths which are being made to reach the Red Hat's autonomous system. Okay, so you can play around with this a little and see like BGP announcements in real time. You can see the dynamic paths which are being made, static paths which are being made, and this is quite interesting to just sit and observe as well. Okay, so now we have kind of seen a real-time autonomous route for Red Hat's website. Uh, One point to note here is the entire internet works on trust, and the owner of the autonomous system needs to take a lot of care not to advertise an IP that the person does not own. Right, so there is an attack called BGP hijacking, which the hackers have come out with. So basically they start announcing IPs which they do not own and start receiving traffic for those particular IP addresses, and this is kind of illegal, and it is something that is not good. So here are a few examples. There is something called as BGP mon, which is used to monitor all the BGP traffic or BGP announcements that are happening, and basically they caught a hacker who was trying to advertise for all these famous websites, right? So you can go read a lot more posts about BGP hijacking on BGP mon. It's quite interesting as well as to how they do that. Okay, and also if you do not understand what BGP hijacking is, there is a tutorial here from Cloudflare, I think. Yep. So you should definitely check this out. So you are basically trying to uh, deviate the traffic, the legitimate traffic, to some IP that you do not own, right? So you kind of take all the traffic to your servers and you can play around with the users. It's as simple as that. Okay. Okay, it's not simple. You might want to check out this tutorial to understand more about BGP hijack. So finally, I have something for you guys to play around with. So we have something called as Internet Core Commander here. Let us quickly have a look at the IPv6. Okay, so if you like games like Star Wars and all of that, this might be a lot more fun for you guys because it involves traveling with a spacecraft, as well as diving into autonomous systems which are present, right? So you can use these keyboard shortcuts which are here to kind of play around. But what I would like to show you here is we can maybe just type BSNL here for ISP, and we see that BSNL has one autonomous system, right? So just for your information, this is IPv6, so you might not see the same information in IPv4. Okay, it's good to see BSNL having presence in IPv6 as well. So basically, it has connected to all these ASNs which are around it. So you can see, oh, it has W software which is kind of connected to BSNL. Okay, they have LinkedIn connecting to it as well. Then they have something called as Neovera and all of these. So basically, BSNL has kind of peered along with all of these. So it's fun to just move around and explore this. It looks more like a galaxy kind of thing. So it's quite interesting. You can do this in your free time and you will definitely enjoy looking at all these stars. Oh, sorry, autonomous systems. Yeah, that's all I want to leave you all with. Okay, I think this has been a really long video, but I am pretty sure you've kind of understood how the internet works after watching this entire video, or you at least know how to procure an IP and how to, have it behind a BGP router listening for traffic, and how other autonomous systems can basically forward traffic to you. This has been quite an interesting video, and thanks for watching. Please do like and share this video so that all your friends as will benefit from it. See you all in the next video.